up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Network Plus 009 certification. So let's get into it. In this video, I'm going to be explaining to you what classful IP addressing is. We're going to be talking about subnetting, what a subnet mask is, and then I'm going to explain to you what classless subnetting is. All right, let's talk about classful IP addresses. So classful IP addressing, this is a method that divides the IP address space for IP version 4 into 5 address classes based on the leading 4 address bits. So you got class A, B, and C. They provide unicast addresses for networks of 3 different network sizes. Then you got class D. This is for multicast networking. And the class E address range, this is for future or experimental purposes. And an IP address, this is divided into 2 fields. You got a network prefix, which is your network ID, and then you have your host ID. And what separates the network ID from the host ID depends on whether the address is a class A, B, or C address. And here's what class A, B, C, D, and E look like broken down. So class A, it ranges from 1 to 126, and it supports 16 million hosts on 127 networks. You got class B, it starts off with a number between 128 and 191, and it supports 65,000 hosts on each of 16,000 networks. Then you got class C, that starts off with the IP address of 192 all the way to 223, and this supports 254 hosts on each of 2 million networks. Then you got class D, 224 to 239, and that is reserved for multicast groups. And then you got class E, 240 to 255, and that is reserved for future use or research and development purposes. So let's talk about subnetting. So subnetting, this is the strategy used to partition a single physical network into more than one smaller logical subnetwork or a subnet. Subnetting allows for an organization to subdivide a large network into smaller, more efficient subnetworks to help minimize traffic and increase network speeds. An IP address includes a network segment and a host segment, and subnets are designed by accepting bits from the IP address's host part and using these bits to assign a number of small subnetworks inside the original network. And subnetting allows an organization to add subnetworks without the need to acquire a new network number from an internet service provider. And here are some of the benefits of subnetting. So it reduces the network traffic by reducing the volume of broadcasts. It helps to surpass the constraints in the local area network. So for example, the maximum number of permitted hosts, and it enables users to access a work network from their homes. So there is no need to open the complete network. All right, so let's talk about a subnet mask. So a subnet mask, this is a 32-bit number created by setting network bits to all ones and setting host bits to all zeros. The subnet mask splits the IP addresses into the network and host addresses, thereby defining which part of the IP address belongs to the network and which part belongs to the host. All right, so let's take a look at the subnet mask classes for A, B, C, D, and E. So as you can see here, you got class A, that's 255.0.0.0. The number 255 represents the 8 bits that identifies the network portion of an IP address. And the 3 zeros, which represents 24 bits, they represent the portion that will be assigned to identifying the host. When it comes to class B, the subnet mask will be 255.255.0.0. The first 16 bits are the 255.255. They identify the network portion of an IP address, and the 0.0 or the last 16 bits, they identify the host IPs that could be assigned to devices. And then you got class C, 255.255.255.0. And once again, the first 3 octets are 255.255.255, or those 24 bits. They identify the host, and the remaining octet, which is identified by the 0, those 8 bits identify the IP addresses that can be assigned to devices on that network. So now let's go ahead and put all of this wonderful knowledge together. So once again, class A, if you see an IP address that starts with the number 1 going all the way to the number 126. That is a class A IP address, and they support 16 million hosts, and each of them has 127 networks, and its subnet mask is going to be 255.0.0.0, where the first 8 bits identify the network portion of that IP address, and the last 24 bits, which are all those zeros, they identify the host IDs that can be assigned to devices on that network. Then you got class B. So if you see an IP address that starts with the the number 128 all the way through the number 191. It can support 65,000 hosts on each of 16,000 networks. Its subnet mask is going to be 255.255.0.0. The first 16 bits represent the network portion, and the last 16 bits are the 0.0. They represent the host IDs. And then we got Class C. So once again, if you see an IP address that starts with the number 192 all the way up to the number 223, that is a Class C IP address, and it can support 254 hosts on each of 2 million networks. And it has a subnet mask of 255.255.255.0, with the first 24 bits identifying the network portion of that IP address, and the last octet or the last 8 bits, they identify the host ID for devices that could be assigned to that network. All right, next let's talk about classless subnetting. So earlier in the video, I talked about classful subnetting, where I explained how to subdivide or subnet an IP version 4 address, which is the strategy that is used to subdivide a large network into smaller, more efficient subnetworks to help minimize traffic and increase network speeds. The problem with classful subnetting is that you are restricted as to how far you can subdivide a network, because classful subnetting focuses purely on the overall class an IP address falls up under, which causes an IP address to potentially have millions of available subdivided IP addresses to utilize, which is very inefficient for most networks. Now I'm going to show you how to apply a concept called classless subnetting, which allows for you to more narrowly subdivide a network into more manageable IP addresses that can be used for a sub network. All right, so the first thing we have to talk about is this concept called CIDR notation. And CIDR, that stands for classless interdomain routing. In CIDR, this is also known as prefix notation or slash notation. And this is a method for allocating IP addresses and for IP routing. CIDR notation was introduced in 1993 to replace the previous classful network addressing architecture on the internet. And its goal was to slow the growth of routing tables on routers across the network and to help slow the rapid exhaustion of IP version 4 addresses. All right, so if you guys have been in my class for a while, you have probably seen this chart once upon a time from me teaching you how to convert from decimal to binary to hexadecimal. So this is our standard binary to decimal conversion chart, where we got binary represented on the left and its decimal equivalent represented on the right. And this is going to help us out when it comes to classless subnetting, which we're going to look at on the next slide. All right, so here's our first example of classless subnetting dealing with a Class A IP address. So our IP address is 101.0.0.1. And just like I told you earlier, our subnet mask for this particular IP address will be 255.0.0.0. And as you can see, it's binary equivalent. All the ones in the first octet are turned on to represent 255. And then the last 24 bits are all turned off, which represent 0. Inside our notation, we would just put a /8 to identify that the first 8 bits have been turned on. That's how simple this is, ladies and gentlemen. All right, here's example 2 of slash notation. We have a Class B address, which is identified by 129.0.0.1. And like I told you earlier, our subnet mask for Class B will be 255.255.0.0, where the first 16 bits are turned on to identify the network portion of the IP address, and the last 16 bits are turned off, which identify the host bits of that IP address. So when we write this out inside our notation, we could just simply write the IP address as 129.0.0.1/16. And the /16 tells us that this is a Class B address, and the first 16 bits have been turned on to identify the network portion of this particular IP address. And obviously the last 16 bits are turned off, which identify the hosts. And next we have a Class C address, 193.0.0.1, subnet mask 255.255.255.0. The first 24 bits are turned on, which identify the network portion of that IP address, and the last 8 bits are turned off, and its CIDR notation is going to be a /24. So you would simply write the IP address out as 193.0.0.1/24. And once again, that /24 lets you know that the first 24 bits of that particular IP address represents the network ID, and the last octet represents the host bits of devices that will be assigned to that network. All right, so now let's take a look at some examples that show you different numbers that don't have to deal with 8, 16, and 24. So we got this IP address of 198.0.0.1/14. So basically, when you look at this IP address with the /14, that tells you that the subnet mask is going to be 255.252.0.0. And basically what that means is the first 14 bits have been turned on to indicate that we're going to have 255 and .252 that identify the network portion of this IP address, and the last 18 bits are turned off, which identify the host bits that could be assigned to devices on this IP address. And remember, an IP version 4 address has a maximum of 32 bits. So you add 14 plus 18, that gets you a grand total of 32 bits. And this chart comes into play with helping you quickly figure out what the decimal equivalent is going to be. So you look at, we got 6 ones turned on right here and 2 zeros. You come down to your chart, 6 ones and 2 zeros, that gets you 252. That's how we ended up with a 252 right here, of the first 14 bits being turned on, which will give us 255.252 and obviously .0.0. Let's look at another example. We got IP address 201.1.0.0 with a /21. Its subnet mask is going to be 255.255.248.0, where the first 21 bits are turned on and the last 11 bits are turned off. All right, so let's look at an example where we lead off with the CIDR notation of /27. So we got /27 that tells us the first 27 bits are going to be turned on. So we got 8 bits here, 8 bits here, 8 bits here, and 3 bits here. Add that all up, that's 27 bits. That leaves us 5 bits that are turned off, which identify the host bits. And obviously all these bits turned on right here is 255, 255.255. And then we come down to our chart, find the first 3 ones that are turned on with 5 zeros following after it, and that lets us know that it is a 224. So our subnet mask for this particular / notation will be 255.255.255.224. So let's take a look at one more example with a CIDR notation of a /19. So we have a subnet mask of 255.255.224.0, where the first 19 bits are turned on and the last 13 bits are turned off, which identify the host bits. All right, next let's talk about IP version 6 CIDR notation. So an IP version 6 address is usually distributed by the Internet Assigned Numbers Authority, or the IANA. The IANA is responsible for providing address blocks to the regional internet registries, who then assign smaller blocks of IP version 6 addresses out to your ISPs or your internet service providers. From there, the ISP will then assign you, the end user, with an IP version 6 address that has a /48 subnet, which you can then further subnet down as needed. And as a side note, you want to remember that an IP version 6 address is 128 bits long, whereas consisting of 8 blocks of 16 bits. And remember that the values are hexadecimal numbers and not decimal numbers. All right, so let's look at an example of an IP version 6 address and how it is broken down. So we got IP version 6 address 2500:AAAA:3333:001: a whole bunch of zeros followed by a 1. The global routing prefixes identify the first 48 bits. So these are the first 48 bits right here. Just remember 16 times 3, that gets you 48. So remember, the Internet Assigned Numbers Authority, they assign this first block right here, 2500. Your regional internet registries, they assign the second block, and your ISP, who you pay your internet bill to, they assign the third block right here. And like I say, all 3 of these, they make up the global routing prefixes, or the first 48 bits of an IP version 6 address. All right, so working with this same IP address, when we get down to the 4th block, this is locally assigned by the end user. And this is used for creating your network ID. So just like with IP version 4, we use subnet mask to identify which portion of the IP address represents the network ID. Well, in an IP version 6 address, this 4th block identifies the network ID of the network your IP addresses are going to reside on. And it could be a 1, 2, 3, 4, etc. And within this, you got 16 bits, and that'll give you a grand total of 65,536 total subnets you could theoretically create just off of this one block alone. All right, then finally we get down to our last 4 blocks, and these are the host IDs. So just like with the IP version 4 address, you had 255.255.255.0 or 255.0.0.0, whatever combination, right, for A, B, and C. So just like with a Class A IP address where I said the subnet mask was 255.0.0.0, and I told you that the subnet mask represents the first octet or the first 8 bits that are turned on, and the remaining 3 octets represents the network IDs that can be assigned to potential devices on that network. Well, in an IP version 6 address, this is what this represents. These last 4 blocks represents the host IDs or IP addresses that can be assigned to various devices within a network. And under this system right here, this would get you approximately 18 million trillion hosts per subnet. So remember, we go back to the last slide when we were dealing with the actual network ID or identifying the subnet. We can get a grand total of 65,536 total subnets. Now, out of those 65,536 total subnets, each of those subnets could potentially host as many as 18 million trillion hosts per subnet. So in case you're wondering why this is, if you go back and check out my IT fundamentals class, I explained in that series that IP version 4 only has a maximum of like 4 billion IP addresses, and we've pretty much exhausted all of them. So in order for us to continue to enjoy the internet where we can surf our iPhones and watch YouTube videos like TechG and order random stuff off Amazon and slide into people's DMs and do all this crazy stuff we like to do, well, we need more IP addresses. And so working with an IP version 6 address where you can have 18 million trillion hosts per subnet, and then you can have a maximum of 65,000 subnets. Well, in theory, we should never, ever run out of IP addresses for at least a couple generations or so. Right, so continuing on with this slideshow here. So when we want to write this out in CIDR notation, we would just simply put this as a /64. So basically, when you're dealing with IP version 6 addresses, all of its CIDR notations are going to be expressed in a /64. And the /64, this represents the subnet mask options of this IP version 6 address. So we got 4 blocks of zeros right here, which make up 64 bits or 4 blocks times 16. But anyways, the whole point is IP version 6 CIDR notation. If you do the shorthand version, which I taught you guys in the A+ class of how to shorten out an IP version 6 address, but its CIDR notation is always going to be /64. And here is a graphical representation where in this picture we have 5 different networks being depicted in here, all expressed by IP version 6, and all of them have the /64 CIDR notation. All right, so that wraps up my lesson. So let's go ahead and get into some of this wonderful check on learning. So the first question is, which of the following IP address ranges belongs to a Class B network? Would it be 10.0.0.0 through 10.255.255.255? Would it be 128 through 129? Would it be 192.168.0.0 through 192.168.255.255? Or would it be 224.0.0.0 through 239.255.255.255? And the correct answer would be, this would be 128.0.0.0 through 191.255.255.255. So Class B IP addresses range from 128 to 191, and these addresses support 65,000 hosts on each network and are commonly used in medium-sized networks. Option A is for Class A, and option C is for Class C, and option D, this is reserved for multicast purposes. Next question. What subnet mask is used for a Class C network by default? Would it be 255.0.0.0, 255.255.0.0, 255.255.255.0, or 255.255.255.255? And of course, the correct answer would be C. So Class C networks that have a default subnet mask of 255.255.255.0. This means that the first 24 bits represent the network portion, while the last 8 bits are used for hosts. And this allows for 254 usable host addresses in each Class C subnet. And Class A uses 255.000. Class B is 255.255.000. And the last one, 255.255.255.255. This is a special mask used for single host subnets. And our final question, which IP class is reserved for multicast addresses? Would it be Class A, B, C, or D? And the correct answer is this will be a Class D address. So Class D addresses, they range from 224.000 to 239.255.255.255, and they are reserved for multicast networking. Unlike Class A, B, and C, Class D does not have a network and host ID structure because it is not used for traditional unicast addressing. Instead, it is designed for group communication where packets are sent to multiple recipients simultaneously.